All right. Hello, everyone. Gordon is showing stripes of his background. So
Hello.
today, we're being produced by Gordon, so he's hanging out with us until we're actually ready to go live.
Yeah. When it's Thanksgiving, fill the live stream with Canadians.
Yes.
Yeah.
Yeah, so happy. I was going to say, I guess it's Happy Friday, Fraser.
Happy Friday. Happy November 26th.
Yes.
Yeah. Did you have like an absolutely normal and mundane dinner last night?
I did. How about you?
Yeah, absolutely. I believe we made a pasta.
Ooh,
It was
I had a little lasagna.
Yeah, there you go.
So my house is me, my husband who's Canadian, and our roommate who's Moldovan. And so we ended up, the Moldovan made 7 pounds of sushi yesterday. We're going to be eating sushi forever. Yeah, so yesterday we literally hung out in the kitchen drinking beer and eating sushi as it was being made. It's smoked salmon and cooked crab.
Okay.
We live in the middle of the country.
Okay. Right. Okay.
Not
fresh fish.
No,
right.
no, that this time of year would have been horrible. But yeah.
Okay. I've got my intro written. I've got my my Audacity is ready. I have the audacity to be ready.
Wow.
I am pulling up one page on my iPad that I want to have as a reference because otherwise I will forget numbers. This has been proven.
Was there a story specifically that you wanted to make sure we talked about?
No, mostly I just wanted to hit on, there's a lot of rocky stuff out there that's differentiated and very much like how you would imagine a planet. And some of it is even larger than Mercury.
Yep.
So yeah, I have something open that will remind me how much bigger than Mercury for Ganymede, because Ganymede is cool and the numbers are worth discussing, but I am incapable of remembering them.
Okay.
You have to know your limits.
No.
Yeah, all
I
right. So
rattle off
Annie,
the diameter of Ganymede in my head.
Dog. All right, trying to reduce the sources of noise. All right, I think I'm going to start us out on the correct scene and then leave it to Gordon. I think by turning on my iPad, I have screwed up my lighting because of course I have. I'm just going to look pale. This is our destiny. All right, computer is yours, Gordon. Dog toy is no longer hers. They cannot hear you. We can hear you.
We can hear you. We can hear Gordon as a mysterious voice. Yeah. A Canadian disembodied voice, eh? All right.
All right.
Say when. Tell me when you're ready.
I am ready.
You ready now? Mm-hmm. How about now? Okay. All right. And now
I should
press
start
record?
recording my audio.
Record?
I'm gonna apparently press record. I will give this a file name later. It's fine. I am now. Record has been pressed.
Okay. You're recording? I'm also recording. All right, here we go. Astronomy Cast, episode 622, Rockier Moons and Giant Asteroids. Welcome to Astronomy Cast.
I didn't catch the first few words of that. I was still pressing record.
Okay, I'm going to stop.
I'm sorry. I'm a terrible human being.
No, you just have bad... You need a faster computer, apparently. All right. Tell me when you're recording.
Go.
Okay. The joke being that Pamela owns the fastest computer that Apple makes. Okay.
Yeah.
Astronomy Cast. Oh, okay. Astronomy Cast. Are you ready? Okay. Astronomy Cast, episode 622, Rockier Moons and Giant Asteroids. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser, Cain, publisher of Universe Today. With me, as always, is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I am doing well. It is one of those blustery fall days that reminds us winter is coming, but at least where I am, it's only slightly damp and only below freezing at night, so I can still enjoy winter coming. I understand you are still only slightly damp, but that could be changing.
Yeah, I mean, I think we talked last week about the disaster that that hit British Columbia, knocking out all of our roads and railways and killed now 5 people, but
geez.
like 20,000 pigs died and hundreds of heads of cattle, and it's been pretty bad. And so now there's 3 more storms inbound. We had one yesterday, which wasn't too bad. We're supposed to get another one on the weekend, and then the bad one is going to be on Tuesday. And that probably won't be as bad as the one we had before, but the problem is that everything's over capacity, everything's still flooded, and so it's just going to pump more water into the whole system. So yeah, we'll see how this all plays out for us. But it's definitely it's been a rough winter for British Columbia for sure.
Yeah, I will take the dead leaves everywhere over that.
Yeah. All right, but we got to do our show.
A
rock is a rock, right? Across the solar system, there are giant rocky asteroids and even gianter, rockier moons. What is the difference between these two families of objects, and where do they come from? We'll talk about it all in a second, but first it's time for a break.
What did you click? Oh, that's because you didn't clear the other layer. There, now it's good. You're fine.
Okay.
You're just not used to it.
And we're back. All right, Pamela. So you threw this into the list. What was your thinking? Why? What is the heart of the conversation that you want to have today about the difference between moons and asteroids?
Well, it wasn't so much the fact that they're different as they're the same. When we started this 15th season of ours, we were discussing Pluto's still not considered a planet, but what exactly is a planet? And as we started to get into some of the geophysics of it, it became clear that there are all of these worlds that in some cases are bigger than Mercury, that have differentiation. And we've never really explained what differentiation is. We've never really explained how common these types of things are. So as we're chewing through the solar system, I figured, well, if we're going to dedicate episodes to gas giants and ice giants, we might as well also dedicate one to, well, rocky things that aren't terrestrial planets, because we're lame and don't allow them to be planets.
All right, so let's take your, I don't know, give me sort of the example, the classic giant asteroid or rocky moon that you want to think about today.
So the classic giant asteroid is Ceres, the OG former planet. We actually have a t-shirt on Redbubble from CosmoQuest about Ceres, the other former planet. It does not get nearly enough attention. This is a massive world that has ice volcanoes, has hills, it's a world. It was called a planet until it developed too many friendships with other things in its orbit. And then as far as moons go, you have to look at Ganymede, which is bigger than Mercury.
And the biggest moon in the solar system.
Exactly.
All right, so let's let's take that knife that we've been slicing planets open with, and let's slice Ceres in half and crack it open and take a look inside. What would we see as an internal composition of Ceres?
Well, it's differentiated, which means that it has heavier materials deeper inside, lighter materials at the surface, and it's believed to actually have pockets of water inside of it. Very, very salty water, briny water. And it's those salts that make some of its hills, volcanoes, look shiny, because as it erupts, that material falls back down and sublimates away the water, leaving behind the salt to make everything look shiny.
So would you get a rocky metallic core like what we have with the Earth?
It's not going to be as big, and I don't know if we actually have enough data to be able to get at that level of detail. The way we get at information like that is we measure what's called the moment of inertia of a world. This tells us how dense it is as a function of radius based on how it rotates. And we can get at this information using spacecraft in orbit around it, but it can get fiddly to get down to the just what is in the core. We occasionally can escape this inability to figure it out based on moment of inertia if there's a magnetic field. And this is where with Ganymede, it has a magnetic field that lets us know that it has this iron core, this metallic core. And Ganymede is really cool because, like I said, it's bigger than Mercury. It has a magnetic field. It's actually a lower density than Mercury. Mercury is one of the densest things in our solar system. And so it has this more asteroid-like composition, but we know there's that metal core.
So, back to Ceres, I'm kind of imagining it's got this more, you say differentiated. Now,
Yes.
Do you mean like differentiated, like it has the heaviest elements are down near the middle? What causes differentiation in a world?
Melting in the original formation with the solar system. So if you think about it, our solar system started out extremely hot, and we're always talking about, well, planets get formed through the combination of planetesimals. So you get small things that come together, you get bigger things that come together. And the mental image that gets put together by this story is often one of like snowballs coming together and getting bigger and bigger, or clods of dirt coming together and getting bigger and bigger, or clods of dirt and ice coming together and getting bigger and bigger. But the problem with that
sounds so gentle. That's
right. It sounds gentle, and it ignores all the heat that was involved in this process. And it turns out that pretty much everything started as molten lumps. And molten lumps means that higher density things are going to sink, lower density things are going to float, and you're going to get differentiation by density over time as they cool. And cooling starts at the surface where the heat's radiating out. So that heat initially gets trapped inside, giving it more time to continue this differentiation, because things, just like a pie, I know a whole lot of Americans have been eating pie this week, just like a pie cools from the crust inwards and you burn your mouth on the apples or cherries inside. Well, if you could bite into an early asteroid, one, I wouldn't recommend that because they are giant rocks, but two, they also melted from the outside in, or froze from the outside in, rather.
right. And I'm sort of imagining like when you like grab a beaker full of beach water or beach sand and water and stuff like that, and then you shake it around, then you'll get like the bigger rocks down at the bottom, and you get smaller rocks on top, and then you get this sort of fine silt that came out of the water, and then you get the water sitting on top. It's essentially
the Brazil nut
differentiating
problem.
itself. The Brazil what? You have to explain this. I don't know what you're talking
So
about.
if you get a canister of mixed nuts and you shake the nuts,
okay.
all the Brazil nuts end up on the bottom, and then the lame things like
Right.
just your half a peanut that has started to fall apart ends up on the surface. So
Got it.
it's the
Okay.
Brazil nut problem.
Okay. All right. We'll talk about this more in a second, but it's time for another break. And we're back. All right. So we talked about differentiation. And now you mentioned with Ceres that there are pockets of water, minerally water inside Ceres. How does that happen?
One of the weird things about geology is water is one of these things that has habits of flowing and altering the chemistry around it, because as it flows, it carries different minerals. It's a solvent, it dissolves things. Here on the planet Earth, the reason that we have things like iron in veins is because it can get transported by water. So within Ceres, you have basically the water ends up pooling in areas that have the correct chemistry, that it can eat out the surroundings. It carries the water around. And it's through this combination of chemistry, density, solvent behavior, you end up with pockets of water instead of this smooth continuum. At first thought, I was always deeply confused, and at one point I think I cornered Emily Lakdawala to get an explanation for this. How is it that you go from a molten object that is constantly getting hit and mixed, and why do you have worlds that aren't a smooth mixture of iron everywhere, of lime everywhere? It's because of the chemistry leading to things segregating out in different ways.
And Ceres, for example, as an asteroid, is so big that it has weird volcanism, has these minerally water cryovolcanism, salty cryovolcanism.
So for reasons we're still trying to figure out, throughout the history of throughout the history of Ceres, we've been able to track down various hillocks of different amounts of peakedness. Over time, they'll settle back down. When you have an active volcano, just like here on Earth, it's going to be more peaked. And these are the places where the fluid is coming out through the surface. And once a given spot becomes inactive, it will slump down and flatten out over time. And we can see on the surface of Ceres this history of, in this case, icy volcanism. People will include Io as an ocean world where the magma is the subsurface ocean. In geology, water and molten lava are very similar. So we only differentiate between Io with its sulfur-rich molten rock magma and worlds like Ceres with its briny water. Who would call that magma? We differentiate between them because of language, but the physics is very much the same.
It's interesting you brought up Io. That would definitely fit within this category of objects that we're talking about.
Exactly.
Like if Io was a little farther away, it would, from Jupiter, it would be much cooler and rocky with probably layers of water and ice and maybe some cryovolcanism, but it wouldn't be this extreme volcano-rich asteroid moon that it is.
Well,
but it is rocky, right?
Yeah, it's totally a rocky moon. It's just those rocks tend to be a little bit on the soft and melty side of things.
Yeah, exactly.
And what's happening here is just tidal forces, and our own planet Earth is dealing with tidal forces from the moon. This is not something unique to Io. This is just, it is most impressive on Io.
Yeah. It's cool. I mean, if you'd asked me to make a list of all of the rocky moons, I probably would have forgotten about Io because it's the rock happens to be molten, but it still does classify. All right, so let's go back to Ganymede. You were jumping around. I'm trying to rein you in here and kind of move through it a little more carefully. So with Ganymede, again, take that knife, slice the Ganymede open, and what are the layers that we probably see inside that moon?
So it definitely has that metallic core that allows it to have its strong magnetic field. Now, what's interesting is as you move out from that metallic core, it's not as dense as Mercury. It has a larger radius than Mercury, but it's not as dense. So there's going to be lower density material, whether it be water pockets, which in this case may be ice pockets. We're not entirely sure because, again, it's not like we've taken a core sample of these worlds, and measuring the moment of inertia only gets us so far. But it's believed that this is another world that probably has subsurface oceans. It has a cratered surface. It's weird because it's not like Europa or Enceladus, where we have clearly that ice surface that is coating a complete ocean underneath. It's more in the category of Pluto, where we can see hints that there's ices, in this case, in the composition, but it has a whole lot of rock. So this is one of these transition objects. It's not a ocean world in so much as it's a world that has rocks and metals and waters. It's a full-fledged world.
All right, we're going to talk more about this and other worlds in a second, but it's time for our last break. And we're back. Okay, so Ganymede, we've talked about Ceres and Ganymede. One, which is the king of all asteroids.
Yes.
The other, which is, I guess, the king of all moons.
Yes.
And we talked a bit about Io. So let's talk a bit more just about some other objects that are really giant rocky objects in the solar system that catch your fancy.
Titan. We have to mention Titan. Yeah. Titan is a world that has an atmosphere that is so thick that a human being wearing wings on their arms could glide around. You'd need a spacesuit. The atmosphere is things that we don't breathe so well.
Well,
like
you wouldn't need a pressure suit though, which is amazing. You'd need a coat and a way to breathe.
You need a pressure suit so you don't get crushed so much. I suspect being bruised up by the atmosphere wouldn't be fun.
Well, it's like 1.5 times the thickness, the atmospheric density of Earth. So you could wear a coat, and but like it's minus 70 Celsius on a good day. So you would need more than a coat, and that's what a spacesuit is starting to do. But you wouldn't need that same kind of pressure. So it would be a simpler apparatus, but you can't breathe the atmosphere.
You would definitely feel squeezed though.
Interesting. Yeah, that would be. It'd be weird to feel more atmosphere. I guess it would be like when you swim down in the water. When are you experiencing more pressure?
Right.
Yeah, that's interesting.
And just drawing in air gets more difficult when you have that extra pressure on your body.
Yeah, yeah.
But different worlds have their own balance of gravity creating a thick atmosphere, cold temperatures creating a thick atmosphere. And you have to find that balance of gravity holding on to the gases. Mars doesn't have enough gravity to hold on to the gases. And a temperature. Mars is too warm. Now, Titan, much smaller than Mars, has sufficient gravity to hold on to heavy molecules. And those molecules can form because its atmosphere is so cold. So you have the triple point of methane and ethane, where these molecules can exist as gases, as liquids, and as ices. So we're finding essentially Great Lakes, small oceans, I don't know how you want to put it, that are methane-ethane mixtures. We see this thick methane atmosphere. And one of the things that's perplexing, and I'm hoping at some point we'll figure this one out, is methane is a molecule that breaks down in ultraviolet light, and our sun kind of creates a lot of ultraviolet light, which means that the methane on Titan is constantly getting destroyed and has to be getting replenished from somewhere. And the kinds of somewheres that we're looking at are both geologic, which would make it geologically active, or life, and life is always a good answer. And there's been some research by folks like Chris. There's been research by folks like Chris McKay, who look at all the different chemicals that exist in the atmosphere as determined by Huygens and Cassini. And the chemistry isn't in equilibrium the way we would expect. So there's something knocking it out of equilibrium, and that's just awesome.
So what is the source of these objects? I mean, do they come from the same originating source, do you think?
What we're starting to understand from looking at other solar systems forming using the Atacama Large Millimeter Array and some of the other massive telescopes out there is you can end up with massive worlds like Saturn and Jupiter that are capable of having their own disk around them that acts like a baby planetary nebula. And that baby planetary nebula, and there's an air compressor going off. We're going to take a pause for the air compressor. I hate that air compressor.
I don't think I've heard it before.
It's on a motion sensor, so it only comes on when somebody goes into the workshop, and I bet Kyle just walked into his workshop. Or a dog. Sometimes dogs walk into his workshop. We need to adjust the camera.
That's
so
clever.
It's only triggered by tall humans. All right. So
it's pretty clever, though, to have an air compressor come on in your workshop when you need it. I love it.
Yeah, exactly. The only problem is like it. Yeah. All right. So Titan exists.
Where they came from.
Where they came from. Thank you.
You've got this.
Yes.
Remember, you've got this tiny
No, I'm back.
planetary system around.
Yes.
Okay.
So these planetary nebula, these planet-forming disks can have within them massive planets with their own moon-forming disk around them. Now, this isn't how you get moons consistently. This is like how Jupiter and Saturn get all of their moons. Other worlds, including like Uranus and Neptune, seem to largely steal their moons. Our own Earth's moons is a giant splash of lightweight materials. But as we're out there looking at Ganymede, Callisto, Io, Europa's icy, we're ignoring it today. As we look out at these giant moons, no matter what their composition is, that are orbiting these giant worlds, they probably formed in situ, and everything else was either stolen or splashed up.
And with the asteroids, their material that just was never able to form into anything bigger because of Jupiter's gravity.
Right. So with Jupiter there grabbing onto so much material, there just wasn't enough stuff left in that band of the solar system where the asteroids are that anything big could form. And on top of that, we're still figuring out the dynamics of how everything ended up where it is. And while it largely looks like most of the asteroids formed in that band between Mars and Jupiter, some of that stuff got there via other means, and then some of the stuff in there got stolen out. Jupiter's an equal opportunity flinger of rocks. And the more we learn, the more complicated it looks.
Yeah, I mean, all of the near Earth objects are actually fairly new.
Yeah.
We have objects that go from the asteroid belt to the region around the Earth over the course of, say, 1 million years, and they're pushed there. They're shoved out constantly by Jupiter, and then they drift into our neighborhood and smash into the Earth, or are kicked out into different orbits because of our interactions, or they smash into Venus or whatever. That this is happening nonstop. It's like a conveyor belt of Jupiter slowly shoving this material out of the asteroid belt and into in the inner solar system. And the number of people always ask me, like, if you could turn all of the asteroids into one object, would you have another planet? And you would end up with
No.
something that is vastly smaller than the mass of the moon. So there just isn't a lot of material, just kilogram for kilogram, in the asteroid belt.
Yeah.
But still, all of those objects are important too, and that's why we spent today talking about them. And now we're done.
Okay, we are done. And this is the part of the show where we really have to just take a second to thank all the people that allow this show to happen. We are funded through all of the good folks who donate to us over on patreon.com/astronomycast. And this week I want to thank Matthias Hayden, Randa, Gregory Singleton, Niall Bruce, The Lonely Sand Person, Jeff Wilson, Omar Del Riviera, Marco Izrasi, Paul Disney, Tim McMarkin, Nate Detweiler, Cooper, Aaron Segrev, Kenneth Ryan, Stephen Shewater, Alex Rain, Shannon Humber, Bongman Mick Bluntsmoke, Dean McDaniel, Don Mundus, Janelle Duncan, Michelle Cullen, Jeremy Kerwin, Karthik Venkatraman, J. Alex Alexanderson, Frodo Tenenbaum, Mark H. Widdick, Philip Grand, Matt Rucker, Abraham Cottrell, Anti-User, Father Prax, Ronald McCoy, John, Mark Stephen Ransnack, Jim McGahan, Shersam, Kimberly Rasick, Moose and Deer, Andrew Stevenson, Dustin Ralph, G-Force 184, Rachel Fry, Samansky, Stephen Calfee, Roland Vormerdam, Jen Greenwald, Glenn McDavid, Planetar, and Elad Avron. Thank you all so much. You allow us to pay Nancy, Beth, Richard to keep our servers happy, to keep our software going. We wouldn't be here without you. Thank you.
Thanks, everybody. We'll see you next week. Okay.
And now we save. First, I'm going to rub my eyeball, though. Oh. You were having audio issues hearing me, weren't you?
Me?
Yeah.
Nope.
No? Okay.
Nope.
Okay.
Nope. Sounded good.
This is 623?
622.
622.
622. Don't you dare dog. That dog is always dogging.
Oh, she is such the dog. Such the dog.
Sometimes our dog is like 3 dogs worth of dog. She's a lot of dog. Sometimes she's just like a regular amount of dog, but many times she's extra dog. Okay. I got a question for you.
Okay.
Do you think that a person flying on Blue Origin or Virgin Galactic and crosses the Kármán line gets astronaut wings or not?
No.
No? They didn't go to space?
So I think we need something different than astronaut wings for people who are just on a carnival ride version. It's just sort of like, I've crossed the Arctic Circle, I've crossed the equator in ships, and it's not the same when you're a passenger on a boat as it is when you're actually a sailor handling the ship. And so I think it's fine for them to say, I have been to space, but I think astronaut is something that requires, like...
So what about the people on Inspiration 4?
They went through training. They had to be able to operate the... They had to deal with a leaky space toilet. They earned it the hard way. We can't hear you, Gordon. You have to switch scenes.
Right.
If you switch scenes, we can hear you, Gordon.
Yeah.
I have switched scenes.
I
was saying they did science.
Those
passengers did science, and I think that was one of the criteria. But I know the FAA has changed their criteria for astronaut wings. They did it in the summer.
What if you go around the Earth once and then land?
I still think you need...
John Glenn, was Alan Shepard an astronaut?
So the way I look at it is,
he was a crew on the spacecraft, right?
If you have received sufficient training to deal with air leaks and holes in your spacesuit and all that sort of craziness, and you have buttons you may need to push, you are an astronaut. So those early astronauts had lots of buttons they had to push. They had to go through a lot of training. They were in pressurized spacesuits. That was not a carnival ride. That was a test flight where they essentially did the space version of a touch and go. So I think it's that being trained to fix shit versus, to use the carnival analogy, they aren't the ones who decide at what point do you get out of your roller coaster ride and walk down the ladders because your ride has gotten stuck. They're the ones who sit there until someone gives them direction.
What if it's a really fancy version of New Shepard where you do fly higher and maybe you do a trip around the Earth once and then land?
Are they?
And you're not trained in any way, shape, or form.
If you're not trained in any way, shape, or form, If you are luggage, you do not get your wings. Annie is dying of laughter in the background.
What if you go to the international? What if you go to a space station, but you still haven't had any advanced training?
So currently you wouldn't be allowed to go to the ISS without training.
Right.
If
you go to the orbital reef, the Blue Origin orbital reef.
Then you're a tourist. It's just like being on a boat that crosses the equator. You're a space tourist. You're not trained.
For a week.
You're not an astronaut. Astronaut is like pilot.
You're not an astronaut?
It's something that requires training.
What if you get astronaut training but you don't go to space?
Then you're an astronaut who has not flown.
Talking like...
What if you get all that training and you fly on a suborbital flight like New Shepard with a bunch of paying passengers, but you've had tons of training.
You are still an untrained astronaut because you are still an unflown astronaut because you have not had to utilize your training.
Okay.
If you do not have to be responsible for using your training, I took ground school and I've been on planes a whole lot of times. That doesn't make me a pilot.
Mm-hmm. I think it doesn't matter. It's Pluto a planet, right? I don't care. I just don't care. So it's interesting. It's interesting to me. Is Pluto a planet, Pamela? It's funny to me that this is an argument that people have because, just who cares?
Yeah. So to me, astronaut is a work title.
Does it?
It's a job title. You earn a job title.
Yeah. Does it denigrate the fabulous adventures that the astronauts have taken? Not really. So anyway, Yeah, yeah. Ron McCoy says Fraser just wants to be an astronaut. Give him a break. I sure don't want to be an astronaut. I really don't. Um, that's interesting though. Luke says it's your job to be an astronaut. If you have to pay, then you're a tourist. I think that's a good. I think that's a good. Yeah, if you're hired.
I
But then again,
think there's
what if you're hired?
I think there's middle ground on that. So like the folks that went up to film the movie on the International Space Station had to get training before they could do that, but they were paying for the opportunity. And that's very much like an actor who has to learn how to legitimately ride horses as part of their job as an actor. They also become an equestrian. So there are areas where you are doing your job, and if you were writing the resume, you would have job title actor, but on the bullet list of responsibilities, astronaut would be a responsibility.
Yeah. But would they get their astronaut wings?
Yes.
That I'm okay with. Yeah.
They would, because the FAA says passengers must have demonstrated activities during flight that were essential to public safety or contributed to human space flight safety.
Yeah. Okay. Anyway, I find it hilarious. I find it hilarious that people are trying to, are trying to create some kind of designation, because obviously there's so many shades of gray in between one and the other, and you could slice that so many different ways that everything is meaningless. And so you can appreciate, I think, each individual mission and go, yeah, you were just spamming a can. Or, yeah, you shot a movie on the International Space Station. Bravo. That was incredible. So I find it hilarious. And it's just going to get worse. And so again, is Pluto a planet? I don't care.
And this is where you and I use the word world.
Yeah, exactly. Because Pluto is interesting in its own right. And so is Ceres, as we learned today. All right.
And you can get the t-shirt on CosmoQuest's Redbubble.
There was a question here. Qualuid asks, what's the fate of rocky moons as the solar system gets older and the sun gets hotter?
So the real issue is, are they in orbits that are causing them to migrate in or migrate out? Because it turns out that tidal forces cause dissipation of energy. And if you are rotating around your world faster than the world is rotating, you go inwards. If you're going around the world slower than the world rotates, so like our own moon, then you move outwards. And this means that we are looking
until the two lock.
Until both are locked, yes.
Both lock until the two are locked.
So with Mars, we're looking at its inner moon is going to be the next moon in the solar system that we know of to tidally disrupt itself. And so
and disappear and crash into Mars.
These are the things that I worry about a lot more. When the sun gets bigger and hotter, it will just like wholesale nom Mercury, probably Venus, possibly Earth. It depends on mass loss rates. But that added heat isn't going to exert enough pressure to remove moons from the worlds they're orbiting. They may get meltier. We may see much more interesting ocean moons.
Yeah, ocean worlds around Jupiter. Be crazy.
It makes me wonder if you could turn Europa into Endor. Things I now need to go calculate.
Yeah, a water world. Yeah, it's a good question. When the sun has reached its red giant phase and has increased its luminosity in the solar system, where does the melt line get to? And do you end up with Europa, Ganymede, Callisto melting and just becoming just blobs of water orbiting around Jupiter?
You have to look at two different factors. One, you have to look at the fact that the sun is expanding out and getting hotter. And so that's bringing the surface closer to where the worlds are now, but it's also undergoing a great deal of mass loss. And as the sun loses mass, those worlds will move out further. And this is where we're not sure if the Earth will be nommed or not. It all depends on how much mass loss occurs and how much we get moved away. So you have to do that double calculation of where do the worlds land.
And you also have to include the tidal heating as part of the overall energy that's in the system. Because if you surrounded Io with water, it would be covered in liquid water right now today. So, interesting to think about.
I'm not sure it would necessarily be covered with water so much as because it's molten the way it is, I don't know how much mixing would occur. Because like the Earth's mantle is full of water. And so I don't know if given the way the volcanoes are constantly getting built, if you'd have sufficient mixing. I just don't know. I have no idea. That is a question for Julie Rathbun.
Marco Parigi asks, do you think that Dimorphos could have water ice in it? That's the target for dark, right?
It's so tiny that
so is it inside or outside the frost line?
So it's inside the frost line. That's why we're able to get to it fairly easily. But so it's so tiny that it may have ices, but it wouldn't be. One moment, please. Hey, what did you find that you stole? Sorry, there was.
I was wondering what that sound was.
Yeah, it was an Eddie. He had stolen things. He was trying to get food out of a food bag, but it was human food, so I stole it. Yes. So
what's the latest?
Go ahead.
What's the latest on James Webb?
So they announced today that it's go for launch. I think the entire astronomical community is going to spend the entirety of January drinking, because that's the only way to deal with the stress.
Day after day after day.
Yeah. So here's the deal. Something happened while they were in the process of mounting it, and a belt snapped. And this caused basically the giant twang that resonated through the spacecraft. And they did an assessment of how bad could it be and decided they're not going to open it up because that would require shipping it again. It would add millions and millions. It would add a year.
You go like, did it cause a problem? I don't know. The only way to find out is to put it on a boat, send it to California, open it up in the clean room, check to make sure everything is fine, close it back up, put it on a boat.
I can't believe they don't have a clean room big enough to check things out down in French Guiana. That just feels wrong.
No, that feels. I mean, it's a big telescope. I don't think there's many clean rooms big enough to support a machine that big.
Yeah, but. So basically something went twang and resonated the entirety of the JWST. They have a launch date of no earlier than December 22nd at this point. I've seen they are go for launch. I have not seen the revised launch date yet. That doesn't mean that as you're listening to this, a launch date hasn't been announced. It just means I've heard only the go for launch part at the time that we're recording this. But one of the things that I learned is they actually have a variety of contingencies for, well, if this thing doesn't deploy correctly, we can still use the JWST in this mode. If this thing doesn't deploy, we can still use JWST in this mode. So they have a lot of different ways to use an incompletely opened up JWST, and that is horrifying. Because because
Right.
like they're planning for things to go wrong ahead of time.
Yeah. Again,
Yeah.
half of Lucy's actuators failed.
Right.
So,
Right.
so what if we lose half of James Webb's actuators?
Drinking. This is how
So
we're
that's
going to get
like,
through it.
yeah, like think about that
going to
big,
take.
the big mirror array. Only half of them, like maybe three of the petals are opened up.
Yeah. Well, and then
Only
the sun
half of
shield.
its solar sail, sun shield is like a
Right.
big mess.
Right. And
Yeah.
it's going to take tens of days to get to its location and then very slowly unfold itself. And just like, I saw a tweet the other day that I fully support this idea. It was like, NASA just needs to secretly launch it so that no one knows and then tell us when it's working. There's no way to secretly launch anything.
By the way.
But,
No.
but just like,
So it'd be like NASA administrator be like, come out and like, oh, and one more thing. And then
right.
there's a new space telescope, just like an Apple presentation, right?
Yeah. I made
There's
the
new
decision.
space telescope and you can use it right now.
So the American Astronomical Society meeting this year is face-to-face in Utah, in St. Louis, not in St. Louis, in Salt Lake City in January. And I was supposed to be going to give...
skeptical.
Yeah, I was supposed to be going to do an invited talk and 2 other presentations. And I made the decision last week that I can't risk it. I'm one of those immune-compromised people you read about. And I already have lung damage from chronic bronchitis and way too many bouts with pneumonia. And in thinking about, so what am I really missing in not going? Because I can watch a lot of the presentations online. I can watch all of the press conferences online. And I'm like, the thing I'm really missing is being in the room during the NASA town hall where they talk about JWST and people want to either throw things or celebrate or both, and all of the gossip.
Right.
And so
yeah.
I am going to truly be missing that gossip, but at least I'll be home safe. So
yeah.
I'm not ready for face-to-face giant
pretty quickly.
conferences.
Yeah. Well, I mean, emotionally, I'm super ready to go back and spend time in giant face-to-face conference. I can't wait to hang out with other human beings.
Yeah.
But I also am not willing to take that kind of a risk for the sort of slight gain. So we continue to hunker down as we near second year of wrapping up 2 years of quarantine madness.
If you want an interesting view on what the future's going to be, Neil Stephenson's new book, which I need to look up the title because it's not a title that just rolls off your tongue. Neil Stephenson's new book, Termination Shock, is set in a post-COVID world where they're dealing with climate change. So it's set like 20 years in the future, basically. I'm sure it says the exact date for where it is in the future. I just haven't I'm not that far enough in yet. But just like, it's a future where everyone starts out socially distanced and wearing masks, and they have apps for it's just sort of like, so this is what the future is going to be. Neil Stephenson is right more often than he's wrong. Okay, so this is what we're looking forward to.
Larry Beckham was mentioning in the comments, and I saw this today, the Mu variant is the new
they
one.
went with Omicron.
No, we're at Omicron.
Omicron?
Yeah.
Okay, all right. Was that the one that they were talking about like today? The one that was out of Southern Africa?
Yeah. So there were rumors that it was going to be Nu, N-U, the Greek letter. But it turned out that one had already been used, and it's Omicron.
Okay. Omicron is awesome. I mean, it's a great name. Stupid disease. But
so there's a ton of flights getting canceled, national borders getting shut down again.
Yeah.
It's a hot
Yeah,
mess.
it sounds like a whole bunch of coronaviruses were put into an arena, had to fight to the death, and this one came out on top and is now
That is
exploring
an
the rest of the
accurate
planet.
description of Darwinian evolution.
Mm-hmm. Yeah. Yep. Yeah. And this is this seems like the party continues.
Yeah.
What are you working on? What's happening? What's coming soon?
I'm working on catching up on a bunch of research, and Tuesday is Giving Tuesday, and we're putting together our campaign because we are still on our mission to bring in $200,000 for the year by increasing the size of our Patreon audience so that everyone who has something to give hopefully is giving a little bit, and we're going to give back by, well, giving as many opportunities to interact and learn as we can to all of our Patreon audience members.
Awesome. I'm working on my newsletter today. Haven't sent it yet. So if you want my weekly email newsletter, you still have time. Go to university.com/newsletter. I had a great interview on Monday with Dr. Alex Tichy from, he works on exomoons. And so he's pretty much one of the top researchers searching for moons around other planets, around other stars. And it's a fascinating conversation because they are like, they could be habitable in ways that planets aren't. So you could have a gas giant with a habitable moon orbiting around a star indoor. So it's a fascinating conversation. So it was a lot of fun to talk about. So definitely check that out. And apart from that, just continue steady as she goes. Just keep on writing, keep on doing more and more interviews and live streams.
Sounds awesome.
Thank you, Pamela. Thank you, Gordon, behind the scenes, joining us today. Thank you to everybody watching us on both YouTube and on Twitch, all the mods. We couldn't do this without all of you. We really appreciate it. And we will see all of you next week. Thanks, everyone.